Find an equation of the line tangent to the curve at the point corresponding to the given value of the parameter. Here we have x equals t to the fourth plus 1, y equals t cubed plus t equals -1. When we're finding an equation of a line, most often we'll use the point-slope form. We can quickly find a point that's on the line by finding, because this is a tangent line, it's also a point on the curve, and it corresponds to t equals -1. So if t equals -1, then x is equal to -1 to the fourth plus 1, which is 1 plus 1, that's 2. And y is equal to -1 cubed plus -1. That's going to be -1 minus 1, which is -2. So our point corresponding to t equals -1 is the point 2, -2. So now we know that an equation of the line would be y minus y1 equals m, the slope, times x minus x1. Here again, m is the slope of the line. x1 and y1 is any point that is on the line, and we just found such a point, 2, -2. So already we can say that our equation should be y minus -2 equals m times x minus 2. The only thing left to do is to find the slope. This line is a tangent line, so the slope will be given by the derivative at this point, 2, -2. Well, this is a set of parametric equations, so remember our derivative, we're still wanting to find the derivative of y with respect to x, and it's going to be at the point 2, -2, which is the same as saying that t is equal to -1. So the slope of the tangent line there is going to be the derivative of y with respect to t divided by the derivative of x with respect to t. Remember, that's how we find our derivative when we're given a set of parametric equations, and we're going to evaluate that when t equals 1. So remember that x is equal to t to the fourth plus 1. Y is equal to t cubed plus t. So let's take that knowledge and put it down here. T to the fourth plus 1, t cubed plus t. So x is t to the fourth plus 1. Y is t cubed plus t. Well, this gives us that the derivative of x with respect to t is 4t cubed. And the derivative of y with respect to t is 3t squared plus 1. Putting those here, the derivative of y with respect to t is 3t squared plus 1 divided by the derivative of x with respect to t is 4t cubed. And now we're going to evaluate that when t is equal to -1. So it just means we're going to substitute -1 everywhere we see t. So 3 times -1 squared plus 1, 4 times -1 cubed. Simplifying, -1 squared is +1 times 3 is 3, plus 1 is 4. -1 cubed is -1 times 4 is -4. So our slope ends up being -1. So finally we can say that y, remember we wrote our equation up here, y minus -2 equals m times x minus 2. We can rewrite that. We know what m is. We can also say that y minus -2 is the same as y plus 2 equals -1 times x minus 2. This is an equation of the line that's tangent to that parametric curve when t is equal to -1. If for some reason we're asked to give this curve in slope-intercept form, remember we could just solve for x. So y plus 2 would be -x plus 2 Subtracting 2 from both sides, we have y equals negative x. So there's also an equation of the line tangent to the given parametric equations, tangent to the given plane curve defined by those parametric equations, at the point where t is equal to negative 1.